In this video, we will be talking about flat bodies and how to plot and visualize them in Matlab. So, why are we talking about flat bodies? Because it is easy to make an irregular body. That's very important. If you actually talk about understand how to just plot or visualize a flat bodies, you can actually make irregular shaped bodies, and it's actually computationally fast as you are going to average surface of the body which may have irregularities to it. That's very computationally very slow if there's irregularities, roughness in it. So if you actually want to assume a body to made of a number of flat surfaces, it will be easy. And you can actually later on, if you want to go add some curvature, convexity to it, you can add it. We'll be talking about that in next lectures. So let's first talk about the regular shaped bodies. Like regular shaped bodies like cuboid, ellipsoid, and sphere. Plotting of these are easy. You just have the function and you can plot it. So let's take for sphere to make it understand. A function f for sphere is represented as x square plus y square plus z square is equal to minus r. This is a function minus r square. This is a function for sphere. Okay, for ellipsoid it's like x square divided by a square plus y square divided by b square divided by c square minus 1. These are the major axis, minor axis, and median axis. Okay, and these takes three values. These functions, if you talk about, they take less than 0, equivalent to 0, and greater than 0. And so if they have a pattern to a function like positive here, negative inside the sphere, and 0 on the surface, you can actually use a function in Matlab to plot it, as I have already shown. You can this time you can actually use iso surface because it's a volume for volume, and its surface would be like on top of it. It would be easy to visualize it. Iso surface can now work fine because we're gonna just visualize the bodies. Okay, if you go for a surface like this one, it will show one surface inside, but you can't just see that because we're gonna only see the outside one. Okay, so iso surface will work fine. So but this is not actually the topic of this lecture, this video. The topic of this video is irregular shaped bodies. And in order to understand how to actually visualize irregular shaped bodies, we have to first understand the flat surfaces. One flat surface I already talked in last lecture. So we're going to have two flat surfaces, and the volume is gonna enclose within. We have to visualize this volume. This is the body. Okay, so let's assume we have two flat surfaces. First, let's say one flat surface which is given by a is equal to 1, b is equal to 0, c is equal to 0, and d is equal to 3. So this is the function to distance of 3. So this function for flat surface 1 would be a x plus by plus cz minus t. Okay, this function will take three values: greater than 0, equivalent to 0, less than 0. Greater than 0, it will be here, like plus 1, plus 2, plus 3, 0 here, and negative here, minus 1, minus 2, minus 3 here, 3 here, 6, minus 6, minus 5, minus 4, like this one, and okay, minus 7. This is the first surface. Now let's talk about the second surface, f2. Let us put it here, and its coordinates vectors, we can give it a minus 1, b 0, c 0, d is 3. For this we can write an equation. So this minus ax, rest is same. It will also take three values: greater than 0, less than 0, equivalent to 0. And for this one, positive would be like this side, 0 would be on the surface, and negative would be on this side, minus 1, minus 2. So if you add these two, f1 plus f2, you can see that this side like minus 7 plus 1. For this one, it would be like minus negative here, negatives here, negatives and negatives here. So this has no pattern to it. this everything is negative. For different flat surfaces, maybe it may attain 0 somewhere, but this one here has no pattern to it, no zeros, no positive, so you can actually segment. You can't actually segment this function. So in order to solve this problem, there's a concept of Macaulay brackets. So this function, let's just say a function f takes value of 0. I'm defining a Macaulay bracket when f is actually less than equivalent to 0, and f function takes value of f when f is greater than 0. Now you will see this problem will be solved. Now let's again plot two surfaces. For this positive here, negative here, then Macaulay will be applied. This will be 0, 0 on the surface, 0 this side. Okay, now for second surface, it will be positive here, 0 on the surface after applying Macaulay, and 0 in within. Now you can see that it is positive this side. After adding f1 plus f2, that's Macaulay, you can see that this Macaulay is positive outside, positive, and 0 inside. Now you can get your volume. So we can generalize this thing as, now you can generalize the function of adding the two surfaces, you will get a volume. How? You're gonna write a function f, this for bodies, is given by summation of I is equivalent to 1 to n. N is number of planes, Macaulay brackets, a I x plus b I x plus c I z, b I y plus c I z minus d. This is the function, and this takes how many values? Two values, greater than 0, equivalent to 0. So for equivalent to 0, it's volume enclosed. Okay, so now we just have to code this up in Matlab, and you will be able to visualize this thing. So for number of surfaces, you can enclose a body of any shape. Now let's say you have a body, this is local coordinate system, this is local origin. You have one surface here, another surface here, and the surface on the top, so this will be zeros. This is on this, and this side you can also put surface this side and that side, and you will see outside this function would be positive, and inside it would be all zeros, and you will get your body. And this is the main concept behind plotting flat bodies. Okay, thank you for watching.